Galileo had been committed to publishing the dialogue concerning the two chief world systems for some time. Already in the Starry Messenger in 1610, he promised to provide a demonstration for the motion of the earth in a future book on what he called the system of the world. During the second decade of the 17th century, Galileo was occupied with replying to, criticizing, and refuting his critics on a number of fronts. Before, during, and after his visit to Rome in 1611 concerning his telescopic observations, in his debates with opponents in Tuscany concerning his views on floating bodies, in arguments with Christopher Scheiner over sunspots, concerning theological objections to Copernican astronomy, and arguments with Orazio Grassi concerning the nature of comets. Galileo also spends time working out details of his discoveries, such as calculating the periods of revolution of the moons of Jupiter. And as we've seen, in March of 1616, the Inquisition orders Galileo not to hold or to defend Copernican astronomy. I've already mentioned that in late 1615, he had circulated a treatise in which he argued that the phenomenon of the ocean tides might provide the kind of evidence which would lead necessarily to the conclusion of the double motion of the earth as the cause. It is this argument which appears in the fourth day of the dialogue. The 1616 injunction of the Inquisition did not prevent the private circulation of Galileo's treatise on the tides, but it did mean that Galileo would have to adjust his plans to write a book on the system of the world, which would have been simply an elaboration of his argument for Copernican astronomy on the basis of the tides. In April 1624, the year after the election of Cardinal Maffeo Barberini as Pope Urban VIII, Galileo journeyed to Rome and had 6 long audiences with his old friend. Galileo had dedicated the Assayer to the newly elected Pope in 1623, and the Pope had listened approvingly as the book was read to him. Reports of their discussion over these 6 audiences indicate that the Pope told Galileo that there would be no problem in discussing Copernican astronomy as long as he restricted his presentation to the hypothetical. We've already encountered one sense of hypothetical in the traditional view that mathematical astronomy was hypothetical in that it simply saved appearances. It could not in principle arrive at the truths of heavenly motions. The distinction between hypothetical and true, and the confusion concerning different senses of hypothetical, play an important role in Galileo's encounter with the Inquisition. In Bellarmino's letter to Foscarini in 1615, which we've already discussed, the Cardinal drew a distinction between mathematical astronomers who speak hypothetically and save appearances by using epicycles, deference, and the like, and physicists who have as their goal the discovery of the true structure of the cosmos. Bellarmino, following Thomas Aquinas, was well aware that Ptolemaic astronomy fell into the former category, for epicycles and eccentrics are geometric devices to describe observed celestial motions, and as such were hypotheses. Geometric entities could not serve as necessary physical causes of the observed motions of the heavens. Bellarmino noted that, since such hypotheses could not, in principle, constitute a true science of the heavens, there was no danger of their being in conflict with biblical truths. As we've seen, Bellarmino did not deny that there can be scientific knowledge about the heavens. He did not think, however, that mathematical astronomy could provide such scientific knowledge. There was considerable ambiguity in the use of the term hypothetical in the early 17th century. Thus, when interlocutors such as Galileo, Bellarmino, Pope Urban VIII, and officers of the Inquisition use this term, they do not always mean the same thing. In addition to the Thomistic tradition in which Bellarmino participated, there was another one according to which the hypothetical status of claims about nature reflected a skepticism about human intelligence. The tendency, that is, to view any claim about human knowledge as hypothetical. This emphasis on the ephemeral, uncertain character of knowledge of the world was reinforced by the voluntaristic theology and nominalistic philosophy of the 14th century. Thus, to affirm divine omnipotence required, so it seemed, the denial of the possibility of human knowledge of the world. Since science, in the traditional Aristotelian sense, was knowledge of a necessary nexus between cause and effect, it seemed that to argue that this type of knowledge is possible was to necessitate God, and hence to deny divine omnipotence. Cardinal Agostino Oreggio, a colleague and friend of Maffeo Barberini, the later Pope Urban VIII, Cardinal Oreggio reports a conversation Barberini had with Galileo sometime in 1615 or 1616. Barberini defended the view that, given God's omnipotence and omniscience, we ought not to bind divine power and wisdom by claiming that any human science knows for sure the way things are. Oreggio was one of the theological consultants engaged by the Inquisition in 1632 to examine Galileo's dialogue. He is also a source for the conversations Pope Urban VIII had with Galileo in 1624, in which the Pope asked Galileo whether he, Galileo, agreed that unless you can show a particular claim about nature contains a contradiction, then you have to admit that God has the power and wisdom to arrange differently from any theory Galileo advances the orbs and stars in such a way as to save the phenomena that appear in the heavens. If God has the power and wisdom to arrange the heavens in a way different from any theory which we propose, while saving all the phenomena, then we must not bind divine power and wisdom by saying that a particular explanation of the heavens is true. The Pope confided to another of his cardinals that there ought to be no fear about Copernican astronomy, since no one could possibly demonstrate it to be necessarily true. It seems that the Pope understood the hypothetical character of Copernican astronomy to mean that it cannot possibly be true. This is a different understanding of hypothetical from that which Aquinas used when he wrote of hypotheses in mathematical astronomy as devices for saving the appearances. They could not be necessarily true, since they did not conform to the principles of a true science of nature. Everyone agreed that it was permissible to use Copernican astronomy as a hypothesis. The epistemological status of a hypothesis, however, was related to the major scientific, philosophical, and theological debates of the period. The interpretation of the concept hypothetical knowledge thus became dependent on the theological and philosophical orientation of the interpreter. One recent scholar has drawn attention to the disputes between the Jesuits and Dominicans concerning grace and free will, which resulted in a tendency toward intellectual skepticism among the Dominicans and changed the status of new forms of knowledge like Copernicanism from that of unproven doctrines to that of unprovable ones. In the discussions surrounding the publication of the dialogue, the Pope's chief theologian, Niccolò Riccardi, wrote to the inquisitors in Florence that the title of the book could not be On the Ebb and Flow of the Tides, and that the opening and closing of the book had to reaffirm the hypothetical nature of the discussion. Riccardi's letter reveals the continuing importance for the Pope of maintaining the hypothetical character of the arguments concerning Copernican astronomy. The Pope thinks, Riccardi wrote, quote, that the title and subject should not focus on the ebb and flow of the tides, but on the mathematical examination of the Copernican position on the Earth's motion, with the aim of proving that, if we remove divine revelation and sacred doctrine, the appearances could be saved with this supposition. End of quotation. Galileo's negotiations with Riccardi in the early summer of 1630 resulted in the inclusion of an introduction to the Discerning Reader, it was called, an introduction to the book in which Galileo claimed that he wrote the dialogue to show that the 1616 prohibition of books that argued for the truth of the new astronomy was not the result of scientific ignorance in Catholic circles. His book would show that Catholic thinkers knew the arguments but rejected them, and he would do this, as he says in his introduction, by, quote, taking the Copernican point of view, proceeding in the manner of a pure mathematical hypothesis, and striving in every contrived way to present it as superior to the viewpoint of the Earth's being motionless. By writing the book in the form of a dialogue among a proponent of Copernicus, Salviati, a supporter of the Ptolemaic and Aristotelian positions, Simplicio, and an intelligent, uncommitted third party, Sagredo, Galileo thought that he would preserve the claim that he, the author, did not hold or teach Copernican astronomy. The arguments Galileo advanced for Copernican astronomy in the text did not claim to be a demonstration for the new astronomy, but nor did they take the form of a mere fictive model to save the phenomena. In the first three parts of the dialogue, Galileo shows that none of the arguments advanced for the immobility of the Earth and the mobility of the Sun are conclusive. In fact, the defender of geostatic astronomy, Simplicio, does not fare well in the dialogue with Sagredo and Salviati. The demolition of arguments against the Earth's motion leads to the discussion in the fourth part of the positive argument for such motion based on the tides. Galileo does follow Riccardi's instructions to emphasize the suppositional character of the arguments in the final part of the book. It is, however, Simplicio, the defender of the discredited geostatic position, who defends the suppositional character of the arguments. And here's the quotation from Simplicio near the end of the dialogue. Simplicio says, "I confess that your ideas concerning the tides seems to me much more ingenious than any others I have heard, but I do not thereby regard it as true and conclusive. Indeed, I always keep before my mind's eye a very firm doctrine, which I once heard from a man of great knowledge and eminence, and before which one must give pause. From it I know what you would answer if both of you, Sagredo and Salviati, are asked whether God, with his infinite power and wisdom, could give to the element of water the back and forth motion we see in it by some means other than by moving the containing basin. I say you will answer that he would have the power and knowledge to do this in many ways, some of them even inconceivable by our intellect. Thus, I immediately conclude that in view of this, it would be excessively bold if someone should want to limit and compel divine power and wisdom to a particular fancy of his." Galileo certainly thought that scientific knowledge of nature was possible. He did not accept the view that appeals to divine omnipotence rendered all human claims to knowledge hypothetical. When authorities in Rome read the book, they were convinced that Galileo had defended in some way Copernican astronomy. He had done precisely what in 1616 he had been enjoined not to do. In the late summer of 1632, the Pope ordered that the publication of the book cease, and he appointed a special commission to examine it. In September 1632, the Papal Commission concluded that Galileo, quote, may have overstepped his instructions by asserting absolutely the Earth's motion and the Sun's immobility, and thus deviating from hypothesis. The Commission noted that when Galileo brought his original manuscript to Rome in 1630, it was clear that although he had been ordered to discuss the Copernican system only as a pure mathematical hypothesis, one found immediately that the book was not like this, but that it spoke absolutely, presenting the reasons for and against without deciding. Thus, in 1630, Riccardi had insisted on a preface and an ending in which Galileo makes it explicit that he's only going to write hypothetically, and that the entire text should conform to this approach. One of the conclusions the Papal Commission reached was that despite the changes in the beginning and end of the book, Galileo had not really followed Riccardi's instructions. The Commission also discovered the 1616 document, according to which the Inquisition instructed Galileo not to hold, teach, or defend Copernican astronomy in any way whatever, orally or in writing. The key phrase, "in any way whatever," plays an important role in the Inquisition's final judgment of Galileo's guilt. One of the theologians asked to review the book for the Inquisition in 1633, Melchior Inquefer, concludes that throughout the book, Galileo proceeds in, quote, "a categorical, absolute, and non-hypothetical manner." No doubt Inquefer is employing the term hypothetical in that sense which opposes it to speaking absolutely. As Inquefer observed, Galileo promises in the book to proceed in the manner of a mathematical hypothesis. But a mathematical hypothesis is not established by physical and necessary conclusions. So Galileo should have posited the Earth's motion as something to be analyzed deductively, not as something to be proved true by destroying the opposite view, as he indeed does in the entire work. So in order to restrict himself to a pure mathematical hypothesis, Inquefer continues, Galileo did not have to prove absolutely that the Earth moves, but only to conceive its motion in the imagination, without assuming it physically, and thereby certain celestial phenomena can be derived, numerous details of their various motions shown. Thus, even though Galileo might say that he did not claim to demonstrate that the Earth moves, he still was not speaking hypothetically in the sense that the authorities in Rome required. In the formal sentence of June 1633, the Inquisition noted that the dialogue explicitly violated the 1616 injunction, since Galileo in this book, quote, defended the opinion of the Earth's motion and the sun's stability, already condemned and so declared to your face, although in the said book you try by means of various subterfuges to give the impression of leaving it undecided and labeled as probable. This is still a very serious error, since there is no way an opinion declared and defined contrary to divine scripture may be probable. Note the argument that one cannot say that an opinion is probable if it has been declared and defined to be contrary to the Bible. It is important to remember the distinction between possible and probable. Probable means that the preponderance of evidence favors a view. Obviously, a Catholic must use the evidence of what Scripture says in determining whether a position is probable. To defend the opinion that the Earth moves and the sun stands still as probable would mean that one had ignored or seriously undervalued the clear evidence of the Bible, so the Inquisition concluded. The certificate Galileo had from Cardinal Bellarmino, dated in May 1616, which Galileo presented at the Inquisition's proceedings in 1633, did not contain the injunction that he should not teach, hold, or defend orally or in writing in any manner whatever Copernican astronomy. This certificate, however, did attest to the fact that Galileo had been told that this opinion was contrary to Scripture, a fact which only aggravated Galileo's case further in the eyes of his judges, since it shows that Galileo knew that the new astronomy was contrary to Scripture, and yet, as the Inquisition says, he dared to treat of it, defend it, and show it as probable. After preliminary discussions before the Inquisition in April 1633, Galileo admitted that his book offered a stronger support for Copernican astronomy than he really intended, and that he regretted the error and would make changes in the book. A summary of the proceedings was sent to the Pope, who decided that Galileo must be interrogated to see what his intentions were in writing the book. This interrogation occurred on the 21st of June, and Galileo denied any malicious intent. The cardinals of the Inquisition who sat in judgment of Galileo concluded that he was, quote, vehemently suspected of heresy. This is a formal category less serious than being guilty of heresy, which would have included a willful perseverance in a false doctrine. Galileo was required to make a public abjuration on the 22nd of June, in which he acknowledged that it was heretical to hold the view that the earth moves and the sun stands still, and that accordingly he rejected such a view. As we've seen, the trial of Galileo before the Inquisition in 1633 and his official abjuration depend on the events of 1616. Pietro Redondi, whom I mentioned before, thinks, however, that the trial was a kind of theater of shadows orchestrated by Pope Urban VIII to protect his friend Galileo and himself from far more serious charges of Eucharistic heresy. Although the specific claims of a behind-the-scene conspiracy on the part of the Pope lacks any evidentiary foundation, Redondi's analysis raises important questions about the relationship between theology and science in the early 17th century. According to Redondi, the offending book is not the dialogue concerning the two chief world systems, published in 1632, but the Assayer, dedicated to Pope Urban VIII and published in 1623. The ostensible subject of the Assayer is a discussion of the nature of comets. It contains an eloquent account of Galileo's philosophy of science. The oft-quoted passage that the book of nature is written in the language of mathematics is found in this book, and the text is a tour de force in scientific methodology. Here is how Redondi categorizes the Assayer. And I quote, "The rejection of dogmatic submission to the principle of authority in the field of philosophy, the vindication of a new language, the rights of research and free intellectual discourse against the prevarication of institutional culture, these were the contents that made the Assayer the manifesto of the new philosophy in Rome. The book was a literary sensation because, even more than the Jesuits, even more than scholastics thought, it seemed to oppose a whole intellectual tradition. The telescope was the instrument through which one looked at the entire universe, and the Assayer was the manual that taught one to read the universe as a book." Redondi discovered in the secret archives of the Inquisition a new document, denouncing arguments in the Assayer, a document which he thinks is the key to unlock the secrets of the Galileo affair. The document is a denunciation to the Inquisition of certain passages in the book in which Galileo argues for atomistic physics. The author of the denunciation points out that the problems of such a physics possess for the doctrine of the real presence of Christ in the Eucharist, a doctrine recently reaffirmed in the Council of Trent's definition of transubstantiation. That doctrine required, so it seemed, an acceptance of the truth of Aristotle's distinction between substance and accident. If one were an atomist, that is, if one thought that reality is exhaustively understood in terms of indivisible particles and their movements in space, how could one also believe that the real accidents of the bread and wine, the color, taste, and the like, remained the same, while the substance of the bread and wine became the body and blood of Christ? As the author of the denunciation to the Inquisition remarks, quote, "In the consecrated host, it is commonly affirmed the sensible species, that is, heat, taste, and so on, persist. Galileo, on the contrary, says that heat and taste, outside of him who perceives them, and hence also in the host, are simply names, that is, they are nothing. One must therefore infer from what Galileo says, that heat and taste do not subsist in the host. The soul experiences horror at the very thought." In the offending passage from the Assayer, Galileo addresses the question of whether heat is a real phenomenon, a property or quality of an object. Ultimately, he concludes that heat is the name we give to a reaction in us. It is not a quality of an external object. His argument in the Assayer is worth citing in some detail. Now I'd like to read this passage from the Assayer, which is the subject of the denunciation. Galileo writes, "Whenever I conceive any material or corporeal substance, I immediately feel the need to think of it as bounded and as having this or that shape, as being large or small in relation to other things and in some specific place at any given time, as being in motion or at rest, as touching or not touching some other body, and as being one in number or few or many. From these conditions I cannot separate such a substance by any stretch of my imagination. But that it may be white or red, bitter or sweet, noisy or silent, and of sweet or foul odor, my mind does not feel compelled to bring in as necessary accompaniments. Without the senses as our guides, reason or imagination unaided would probably never arrive at qualities like these. Hence I think that tastes, odors, colors, and so on are no more than mere names so far as the objects in which we place them is concerned, and that they reside only in the consciousness. Hence, if the living creature were removed, all these qualities would be wiped away and annihilated. To excite in us tastes, odors, and sounds, I believe that nothing is required in external bodies except shapes, numbers, and slow or rapid movements. Those materials which produce heat in us and make us feel warmth, which are known by the general name of fire, would then be a multitude of minute particles having certain shapes and moving with certain velocities. Meeting with our bodies, they penetrate by means of their extreme subtlety, and their touch as felt by us when they pass through our substance is the sensation we call heat." Well, the Catholic doctrine of the Eucharist requires that one believes that the whole substance of the bread, and these are the words of the Council of Trent, the whole substance of the bread and the whole substance of the wine change into the body and blood of Christ, with only the appearances of bread and wine remaining. If the distinction between the substance of the bread and wine and the taste, color, and like of the bread is denied, how can one adhere to the Council of Trent's definition of transubstantiation? Yet it is precisely such a distinction between substance and accidents, between the substance of the bread and wine and the accidents of taste, color, and the like. It is precisely such a distinction between substance and accidents which an atomistic physics denies. Thus the threat of such a physics for Eucharistic theology. The doctrine of transubstantiation required a substance be separated even from its extension, that is, its quantity, such that a new substance, that is Christ, could come into being, while the accidental forms of bread and wine, the extension, color, taste, etc., were miraculously sustained in the separated quantity of the bread and wine. The content of faith, that is, the real presence of Christ, was made intelligible by using categories of Aristotelian physics. The threat of atomism, according to Redondi, is that there is no distinction, in fact there cannot be a distinction, between the quantitative extension of a thing however small, and the substantial reality of the thing. Thus, an atom of bread is not separable into substance and its various accidents. If the extended body of bread existed, then no change has taken place. Transubstantiation, which affirms precisely such a change, is thus unintelligible. In the words of the individual who denounced the assayer to the Inquisition, the soul experiences horror at the very thought. Rodandi thinks that beneath the words heat, smell, and taste lay centuries of Eucharistic debate which had again become topical. Neither Galileo nor the theologians could be unaware that Aristotelian philosophy was wedded to scholastic theology through the dominant interpretation of these words. The assayer proposed a materialistic theory of sensible phenomena to sever the knot, to separate natural philosophy from scholastic theology. Such is Rodandi's argument. And as we've seen, according to Rodandi, the assayer served as a manifesto for a new culture, which, in the eyes of the defenders of Tridentine Catholicism, had to be resisted. The Galileo affair, thus, must be seen as part of a battle between an old guard and the new regime of Pope Urban VIII. This is the context in which, according to Rodandi, the Pope seeks to deflect the charges of Eucharistic heresy by ordering a trial based on Galileo's defense of Copernican astronomy. Rodandi is right in emphasizing the importance of understanding the controversy between Galileo and the Inquisition in its historical context, and he provides an excellent description of the cultural climate of the early 17th century. He reminds us again and again of the nexus of theology, the natural sciences, literature, and the arts. Although Rodandi's reconstruction of the cultural world of the Galileo affair is compelling, that reconstruction serves as a kind of Procrustean bed into which he forces the evidence of the trial, or better, simply ignores the evidence of what he calls a theater of shadows. Rodandi persuades himself that his thesis must be true because he is unable to accept that the theologians of the Inquisition could take seriously the problem of the relationship between the Bible and Copernican astronomy. I hope that I've been able to show you how it is that the theologians could and indeed take seriously the question of the relationship between the Bible and Copernican astronomy. Well, finally then, how do we understand the Galileo affair? Despite the powerful legend of the warfare between science and theology, we need to recognize that the errors in judgment committed by the theologians of the Inquisition involve the subordination of the interpretation of certain biblical passages to a particular cosmology, and that these errors resulted in disciplinary abuses, not doctrinal falsehoods. Without a demonstration for the motion of the earth, it was indeed possible to believe that the Bible affirmed that the earth did not move. To insist upon such an affirmation, however, is to violate principles established by Augustine and Aquinas. Nevertheless, the controversy between Galileo and the Inquisition is inconceivable were it not the case that both sides shared common principles, the complementarity between faith and reason, the Bible and science, the role of the Church as the authentic interpreter of Scripture, and a commitment to an Aristotelian ideal of demonstration in science. In an ironic sense, we might say that the Galileo affair offers ample testimony not for the warfare between science and theology, but for the harmony between the two.